All right, algebra students, looking at systems of linear inequalities, and we're going to do a quick review in this video as well. A quick review of writing word problems for systems, because you're going to see that in class next time along with these inequalities. So let's get started. So these are systems of inequalities here. The inequalities, remember, has the line with the shading. So line type, shading. So this is two examples. Let's look at some definitions. A system of linear inequalities made up of two or more linear inequalities. So when you graph them, you get one inequality graphed, the other inequality graphed. The solution to this system is an ordered pair that makes all the inequalities in the system true. In this case, both true. So that will be this lavender region here. So a point is only a solution to the system if it exists in this region. Like the point 5, -2, that one is a solution, but the point -1, 1, or the point -1, -5, or the point 2, 3, those are not solutions because they're not in both shaded regions. So we're not going to waste any time here. We're going to get right to it. We're going to graph three systems of inequalities. So yes, you are going to need yourself some graph paper, hence the meme on the first page. You must be plotting something. So let's get to it. Okay, so our first example, we have x is greater than or equal to 3 and y is less than -2. Now we learned that a vertical and a horizontal line, or vertical and horizontal lines, are specifically equations where you have only the x or the y. Now we had a bit of an editing jump there, I had my phone ringing. So again, horizontal and vertical lines, you only have x or y. So the acronym that we learned, and you should be committing this one to memory, is HOI-VUX. Okay, Rankin's kids know this from last year. If not, HOI, horizontal lines, O for 0, 0 slope, y only equation. V vertical, undefined slope, x only equation. So this first one here, this is a vertical line, the first one that I have out of the two in your system here. So this, we're going to make it blue, it's a vertical line. It's a vertical line where x equals 3. So rather than getting confused or trying to remember or not being sure what to do, plot yourself several points where x has a value of 3. So there, way down here, and pretty quickly you should recognize, oh, it's a vertical line. It's also a solid line because it's an or equal to, and it says greater than. So on the x inequalities here, we're going to shade to the right because that's where the x values are greater than 3. Let's switch colors. I'll use, let's see, we'll use green. So this one's a vertical line, and it's vertical where y equals 2. So again, plot some points where y is equal to 2. Oh, good. So it's here. Now this time, it is not an or equal to. It is not an or equal to. It is a less than, so we shade down. And you can see our crosshatch region is this section here. So this is our solution set. This is where the ordered pairs can be found that make both inequalities true. So that's it. That's all we have going with this. We got to graph them and look at where they overlap. There are applications we'll do in class. We'll do 1 or 2 consumer applications with this that can show you how this would actually be useful in the real world. But this is what you do with a system of inequalities. All right, so here's our next one, and again, we're going to color code. So let's use red for the first one, orange for the second one. If you're feeling super confident, why don't you go ahead and graph it yourself, but I'm going to go through the steps one at a time. So the first one is ready to go. It's solved for y. It's got a y-intercept of -3. So we have here y is less than 2x minus 3. So we're graphing the line y equals 2x minus 3. So it has a y-intercept of -3 and a slope of 2. So that means I'm going to do rise of 2, run of 1. Rise of 2, run of 1. And I don't draw the line until I've actually put all of the points down on the page, because I know that some of these lines are solid and some are broken. So if I choose to draw the line early and then it's supposed to be broken, then it's a pain in the butt and I got to go back and make it a broken line. So this one is broken. So I just like to give each of my dots a little tail, essentially like connecting every other dot kind of. And we want less than. Now less than means we're shading downwards. If you look, I'll use my finger pointer here. So here's our line. We want what's under the line, downward from the line, because it's less than. You can very quickly double check that by plugging in a value. I like to use 0, 0 because it's easy to plug in. Let's do that real quick. for this first one. We get 0 is less than 2 times 0 minus 3. 0 is less than negative 3. False. So the ordered pair 0, 0, not on that shaded region. You can see right here it's not covered in the shading. We shaded the other way. All right, the orange one is not ready. The orange one is not solved for y, but it's easily solved for y if we go ahead and take the moment to write out the work. We're going to subtract 2x from each side. And we get y is greater than negative 2x plus 2. So y-intercept this time is positive 2. Slope of negative 2. So down 2, right 1. Down 2, right 1. Now I know we're looking at that and like, oh no, they don't cross at a point. I'm not going to be able to tell where the solution is. Sure you can, because the solution is not an individual ordered pair, remember? It's the region, the overlapping region of ordered pairs. So I messed up a little bit there. Started to draw my line without thinking. Got to remember it's a broken line because it's not or equal to. So broken, 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 broken. Arrows. Now, it's again a greater than. You can see it right here. It's a greater than. So we want it this time again. So this time, different from the other one, we want to shade up. And again, you can see your crosshatch region is the section with the double shading. So it's this here. This section here. So any point in there is a solution. Once you put 2 in your margin, put 2 solutions for this particular system. So 2 solutions. Put that in the margin of your paper. All right, one more. Okay, so this one, again, one of them solved for y, the other one is not. If you're getting the hang of this and you want to go ahead and pause it, write it out yourself, that's awesome, and then you can take a look at my work after. I'm going to be lazy and do this bottom one first because, again, it is solved for y, so I do have my y-intercept and my slope. So my y-intercept is negative 3, so I'm going to start by putting a point at negative 3. Then I need a slope of 1/3. Now I want you to think about that slope of 1/3. That means positive 1 over positive 3, or it means negative 1 over negative 3. And we need to be able to adapt using both of those. And that's something that I want a lot of you to try working on. So rise of 1, run of 3 puts me here. Rise of 1, run of 3 puts me here. But then this other one, rise of negative 1, run of negative 3 puts me here on the same trajectory, the same path. Same path. And this one is an or equal to, so this one will be a solid line. Oh, I kind of missed. Can I back out of that? Hold on. Ah, good enough. I did my best. Now it's clearly really a solid line. And it's a less than, so we're going to shade down. Okay. All right, so the next one, this teal one up here, unfortunately not solved for y. So we're going to have to go through and solve that for y. So 3y is greater than x plus 6. We're going to divide everything by 3. So we get y is greater than, remember what this is. This is 1/3 x, and then 6 over 3 is 2. So y-intercept of 2, slope of 1/3. Well, the slope sounds familiar. Let's go ahead and graph it. Y-intercept of 2, slope of 1/3. So rise of 1, run of 3, plot a point. Same thing. Go the other direction, rise of negative 1, run of negative 3, plot your points. This one is not solid. This one is broken. And it is shaded up because it's a greater than. So you know what? If you look at this, you've got this gigantic region in the center with no shading. So this system actually has no solution because there's no overlapping region. Fascinating, isn't it? So you can imagine there's lots of other scenarios you could have, and we will look at some. I will also teach you how to graph these with the shading part on your graphing calculator. So that's kind of exciting. But in the meantime, since we're going to be moving also back towards using applications for systems, we're going to be looking at word problems. Let's just do a quick review of that. It's been a while since most of you watched that video. So in these problems, systems word problems, you're going to define 2 variables. You're going to write 2 equations. Then you're going to solve the system with any method and express your answer in an appropriate way, which is usually not going to be an ordered pair. Okay, it's usually going to be X pineapples and Y Volkswagen Beetles. Those are like always my go-to things. I don't know why. But anyway, it's not going to be X comma Y in parentheses for these. It's going to be 2 amounts of something. Okay, let's look at my one example in this video. You have just enough money in your pocket to pay $1.95 for a drink at 7-Eleven. You have 12 coins, which are all quarters and dimes. Write and solve a system of equations to find the number of each type of coin you have. All right, let's do this. First of all, pick a color. I really like that teal color. I'm going to stick to that. So first of all, we got to define our variables. I'm an X and Y kind of girl. I'm a traditional lady. You could use D for dimes and Q for quarters if you want, but still, please write it down on the paper. I'm going to use X for number of quarters. And I'm going to use Y for number of dimes. And I know I have 12 coins total. So there's the first equation, super easy to write, just 12, X plus Y equals 12. Awesome. Now, the other equation I can write has to do with the amount of money I have. If I have $1.95, I can write an equation using the value of each kind of coin. So I would put 0.25x to be the value of X quarters, not 25x, unless I'm going to make this value 195. See, this is in terms of dollars right here, not pennies. So you want to be careful, make sure that's a 0.25, not a 25. Plus, well, you probably already figured out what you're putting for the other one, 0.1y, because it's dimes, because the value of a dime is 10 cents, and the value of a quarter, we use the 25 because that's 25 cents. And now you have your system of equations to solve. Now, I prefer to use methods that make it easier for myself. I like elimination. And most of you will probably find that that's going to be your go-to method because it's easy to manipulate the equations to give us what we want for elimination. In fact, I'm going to multiply this entire top equation by -10, and I'm going to multiply this entire bottom equation by 100, and in a moment you'll see why. And now you see why, because now I can add straight down, and the number of dimes it eliminates. We end up with 15x equals, I believe it's going to be 75. Yes, 75. And that does go evenly. X equals 5. So the answer to our question is not x equals 5. I know many of you are saying, well, yeah, because we have to go find y as well, and y is 7, because if there's 12 total, then there's 5 and 7. But y equals 7 and x equals 5 is still not my answer, nor is the ordered pair 7-5, or 5-7 for that matter. 7-5 would definitely be wrong, but 5-7 is wrong as well, because the answer to the question is, let's use a different color. The answer is, I have 5 quarters and 7 dimes. That's the answer to the question. And that's it for our stuff with systems. And that's actually the last of the instruction you're going to need before we have our systems test. I hope you enjoyed it. Get on your Khan Academy and your IXL and rack up that time so you can get that grade, folks. I'll see you in class.